Hi students, let's understand Ohm's law. The Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. And there are certain conditions. The conditions are the temperature should be constant and the dimensions of the conductor should be constant. So under such conditions where the temperature is constant and the dimension of the conductor or the physical conditions of the conductor is constant, so Ohm's law states that voltage across a conductor is directly proportional to the current flowing through it. Now one thing which you should note is that we have to always state Ohm's law as voltage across a conductor is directly proportional to the current flowing through it. We should not say that current is directly proportional to the voltage. That comes under the explanation part. So whenever Ohm's law is asked, you have to say voltage across a conductor is directly proportional to the current flowing through it under constant temperature and constant dimension of the conductor. Okay, now see, the voltage is directly proportional to the current. Now V is the voltage or the potential difference and I is the current flowing through the electric circuit. So now we can say voltage is equal to Ki, where K is the constant of proportionality and K is the resistance of the conductor also. So when K is equal to R, so our voltage will be equal to the product of current and the resistance. So now when we have V is equal to IR, then we can say as the explanation of Ohm's law that current flowing through the conductor or the circuit is directly proportional to the voltage or the potential difference, and current has a linear relationship with the voltage. So this becomes the formula for Ohm's law. V is equal to IR, where V is the voltage, its unit is in volts, I is the current and its unit is in ampere, and R is the constant of proportionality known as the resistance of the conductor. So unit of resistance is ohms, and this is the symbol of resistance. Now if you see the graph between voltage and current, even on the y-axis we have taken the voltage and on the x-axis we have taken the current. So clearly it shows the relation between the voltage and the current is a linear relationship. The slope of the graph shows that it is a linear relationship. Okay. So the slope of the line is constant, hence it's a linear relation between voltage and the current. So now let's see what is resistance. So as per the Ohm's law, there is a relation between the current flowing through the conductor and the potential difference across it. It is given by V is equal to IR, where R is the resistance. So when we calculate resistance, R becomes V divided by I. So you can see in this diagram, this is the circuit showing current flowing through this conductor and R is the resistance. Okay. So basically what is resistance? Resistance is the obstruction offered to the current when it flows through the circuit. So when the current is flowing through this conductor, this wire, okay, the electrons which are present inside it are offering path to the current. So depending upon the material of this conductor, so the resistance will vary. Now resistance also depends upon the length of the conductor and the cross-section area of the conductor. So resistance will be more if the length of the conductor is more, and resistance will be less if the area of the cross-section is more. That means if you have a thick wire as a conductor, so resistance will be less. If you have L, which is the length of the conductor. If the wire is very long, then also the resistance will be higher. And it also depends upon rho, which is the resistivity of the conductor. So the resistivity varies for different materials. So when we use different materials as conductor, this resistivity will affect the resistance of the circuit. If you are using a very good conductor, so the resistivity will be low, and if you are using a conductor which is not very ideal for current flow, then the resistivity will be high. So the total resistance will be very high. Okay. So the factors which are affecting the resistance are the cross section area of the conductor, length of the conductor, the material of the conductor used, and the temperature of the conducting material. Okay. So why temperature? See, even the Ohm's law says that temperature has to be constant. Because if the temperature of the wire which is carrying the current increases, so what will happen? The movement of the electron inside the conductor will increase. So when the intermolecular activity increases, there is a resistance to the flow of current. So this will start opposing the flow of current. So this is why Ohm's law states that the temperature has to be constant. We have finished the explanation of Ohm's law. So basically Ohm's law describes the fundamental relationship between voltage, current and resistance of a circuit. Okay. So finally we have to say voltage across a conductor is directly proportional to the current flow, and the conditions are the temperature should be constant and the physical conditions of the conductor or the dimensions of the conductor should be constant. So students, let's close this session. If you like this video, please share and subscribe. Do give your comments in the comment section, and please give your feedback and also tell me which videos you want me to make for you. Okay, bye.